We're back with the Spartan 7 board from Seed Studio, and today we will do a communication between the computer and the FPGA using USB to UART. So from the FPGA we will send data from 0 to 9, incrementing it every 1 second, and also from the computer we will send commands like B to turn on the LED and A to turn it back off. So let's get started with the project. Okay, but before we go into the project for the FPGA, let's take a look where we have to make the connections to the ESP. So we got the package for the ESP, and we can see that those pins are connected to the USB to UART converter, and taking a closer look, we can see we got the ESP SDA pin and ESP SCL pin, which are connected to the FPGA and can be used freely for communication. We also got pins here, but those are reserved for programming purposes, so downloading the Bitstream to the FPGA. So let's find those pins. So right here we got a analog switch, so we got the connection between the ESP and the FPGA here. So let's find those pins. And we can see they are right here, so we can make connections between the FPGA and the ESP. So now let's take a look at the project for the ESP. So those pins we have to use together with the software serial, and to do this we have to download the library for it. So you have to go for the managing of the libraries, and let's type in ESP software serial, and this is the library you have to install. After you got this, I also changed the Bitstream that is loading directly from the root folder of the micro SD card, and it's named syspack. So we got the main loop, and right here you got the FPGA already programmed. So in the main loop I did a infinite loop, so this is something close to a main, and here I make the pin definitions, so the input for the receiving, out for text output, and this is the definition for the software serial, so 8 bits of data and 1 stop bit, and this is the baud rate. So in the infinite loop I check for available data from the software serial, and if there is something available I send it to the USB converter, and the other way around, so data coming from the USB converter goes to the software serial. So this is the communication for the FPGA on the ESP side. And now let's take a look at the project for the FPGA. So first the definitions for the pins. So just like on the datasheet, we got the pins for the UART, and in the behavior file we got also the pin connections used as output inputs, the part for the clocking signal, and for the UART. So in this case we've got a 100 megahertz clock, and we want to use the default baud rate, so 115 to 100. So we got this many times to get the clock. So instead of this, it will be this value. So this many times we have to get the clock event for one bit of sending the data through the UART. And here we got some signals for checking the state of the sending. And right here we got the receive buffer here, so we store the received message for later comparing. So this section is getting the clocking. So after 1 second we increment the text value from 0, this is in ASCII 0, and this is 9. So it goes from 0 to 9, and every second it's incremented. And after this we got a process that is handling the sending of the value and a additional new line. So we get the clock events here, and after the value that is responsible for the 1 bit of UART data, so this value, we simply increment the signal, and if we got the button 1 first pressed, so we do the sending. So the start bit, the data bits right here, so this is our variable that goes from 0 to 9, and after this we have to send the stop bit right here, and right here we do the new line sending. So this is a fixed value that is 10 in decimal for a new line. So again, the stop bit, the data bits, and the stop bit. And after this we simply wait a little bit, and if we check the U clock signal, we can see that we only use from 0 to 19 bits of data sending, and to this value we simply wait so that the ESP can recover the data and send it back. Okay, and right now we got the receiving part, so we got also checking the clock, and we check if the UART is ready for receiving data. So if it is, we change the state, and if the state is the bit 0, so the start bit, we start the receiving. So at every half of the bit length, so this value divided by 2, we get each bit. So right here we got the start bit, so we don't care for this value, it's always low. And after this we get the value from every half of the length of the bit, and store it in our variable, and increment the index of the variable and the time we have to make a compare, so the iterate. And after this we listen for the stop bit, so all the bytes have been received, -1, so we don't get into this loop again. Just one step before, and we make sure that we stop receiving the data, and this is it. And after this we got checking for what we have received. So if we got received A in ASCII, so 97, so we can look it up right here. So the A is 97, B is 98 decimal in ASCII. So receiving A results in clearing up the LED, and receiving B turns it on. And also at the end we flash the green LED every 1 second. We change the state, so blinks for 1 second, stays clear for 1 second. Okay, so let's add something here. For example, let's listen for the chart C, and if we receive it, we will blink the LED just like the green LED. So we will do something like this. So let's save it, and let's click generate Bitstream. Okay, and after we got this generated, so let's get the micro SD card inserted. Okay, and now let's take a look here. I got a script that downloads the generated bitstream right to the micro SD card. So let's install it. Okay, so now let's get the card inserted into the board. Okay, so I'm inserting the micro SD card, and you can reset the board by pressing the reset, but it sometimes doesn't work, or you can just simply replug the USB. So we got the FPGA programmed, so let's send something. Okay, so now let's open it up again, and let's add a new command, so this time C, and let's send it. And now we've got both of the LEDs flashing at the same time, and we can send, for example, turn it on all the time, or completely turn it off, and it all works. And it also works if you are sending data to the computer, and it all works. So thanks for watching, hope you find it useful in your projects, and see you in the next one.